Hello, so today we'll discuss about salient features of DNA. This comes under molecular basis of inheritance chapter. So first, if I talk about RNA, in RNA, every nucleotide residue has an additional OH group present at 2' position in the ribose. So if I talk about RNA, their OH that is present at 2' position in the ribose. So in RNA, uracil is found at place of thymine. So thymine is replaced by uracil. So the chemical name of thymine is 5-methyl uracil. If methyl is attached at 5' position, then thymine becomes uracil. Then coming to DNA. So DNA was first identified by Friedrich Mischer. So to make it easy, you can remember the name like fried rice. You can easily remember Friedrich Mischer in 1869. So he named it nuclein. So in 1953, James Watson and Francis Crick, they proposed double helix model for the structure. In short, we remember them Watson and Crick. So one striking feature was that there was base pairing between two strands of polynucleotide chain. So if there was base pairing, that was a unique property. So they're said to be complementary to each other. Okay, so first feature. Now coming to its features. Okay, let's first see the difference between sugars of DNA as well as RNA. This is about RNA. This now talking about DNA. So here we have ribose sugar at second position only, but instead of OH here we have H. Here the sugar is deoxyribose, whereas in RNA the sugar is ribose. So now the structure is like this. Ribose means it's a 5-carbon chain. First position Then this is second. At second position we have OH. Okay, and then third, here this we have OH. This will be H. Fourth carbon and fifth carbon, CH2OH, here H. Now if I talk about RNA, same, everything will be same. Number one carbon will be like this, OH, H. Here we have carbon. Number 2 carbon, H. Here comes OH. Number 3 carbon will be same, OH, here H. This will be number 4 carbon and number 5 carbon, CH2OH, here H. So what's the difference? Difference is here we have OH and in DNA here we have H. So this is the difference between sugars of DNA and RNA. Then coming to its structure, like how a chain is formed. We have heard about like a polymer is formed, a polynucleotide chain. You know how this is formed? Like let's say we have a structure like this. The main idea is 5 dash, there is a linkage 5 dash phosphate and 3 dash OH. Now again I will draw structure. Now how a chain is formed. CH2OH, then again this phosphate, and let's say here we have adenine. Then again similar structure. Let's say I have cytosine here, CH2OH, and here I have phosphate. Now I pick up this 5 dash and this 3 dash. Here we have OH. This will get this OH and this phosphate. So this OH will be replaced as a water molecule, minus H2O. 1H from here, OH from here. Similarly, this will be like this. OH will be moved out. 1H from here. H was removed, hence O is left here. This O is left here. Then P, the structure is somewhat like this: OH, here O. Okay, and now this O this is CH2. Since now this OH is removed and we are left with this O. So this is that O. So this is how phosphoester bond is formed, or you can say polynucleotide chain is formed. Okay, let's do a little bit of glycosidic bond also. Next we have glycosidic bond. This is between two glucose sugars. It will be like this. HOH, HOH, OH, OH, H, CH2OH. This is carbon number 1, carbon number 2, 3, 4, 5 and 6. Again, this side I will draw another glucose molecule. Glucose is 6 number of carbons are there in glucose molecules. In ribose we have 5. HOH, HOH. At third position the position will be reversed. Then same HOH. The difference is only at third position, rest all is same. CH2OH. Carbon 1, 2, 3, 4, 5 and 6. Now here water molecule will be lost. This OH and this H. Okay, so this will result in, the bond will look like this. Here we have H, here we have H, O. So this forms the glycosidic bond.